Hello, we're back again. How's everybody there? Yes, do you got your coffee? Yes, I drink coffee out of a beer stein. That's a lot of coffee, and I like it. Mm. My wife has got me onto stevia, to be healthier, because sugar is the new smoking, right? So it's just got a weird taste to it. But keeps my wife happy. Happy wife, happy life, as we say. I hope you guys are doing all right. I hope you guys are enjoying the day off. If you guys are somewhere, or I'm sure you guys have school there. But which one is my favorite? Coffee. Which one is my what? Stevia or sugar? Um, I find now that my wife she's got me onto stevia, which isn't as sweet. And now when I have something with real sugar in it, it just kind of, whoa, man, that's so sweet. But I don't know. The good movie there called, I think I told you guys there about that. It's called Fed Up. I just typed that in there, and it's a good one. It's a really good movie. It's a documentary on YouTube there. It just details how bad sugar is, and even when you instead of getting real full fat mayonnaise, you can get light mayonnaise, which is supposedly has half the fat. But what they do is they'll just dump in 3 times the amount of sugar to compensate. And we all know that your body can change sugar into fat anyway, so it's just a scam. So just know your, knowledge is power. That's what it all is. Let me get my PowerPoint going here. I am recording, and now I want to. It's been a while since I've used WebEx. I like it. Okay. Good. So we just went into there a bit about the limbic system, okay, which leads us into what's called RAS, and your reticulating activating system. And this one here, this is what I was talking about there earlier. It's just the ability there for us it's our filtering system. And we filter out what we don't want. So maybe even on an unconscious level, I just, I don't know. Let's just think of something silly here. Maybe I hate bananas. Hate them. I don't. Bananas are great. But, let's just say I hate bananas. So unconsciously, subconsciously, you remove bananas from your filtering system, so your body isn't even looking for bananas. Like when you're walking through, think about it. When you're walking through the supermarket, in your mind, you know what you like. So you're looking for those things. The things there that you don't like, do you notice you don't even see them? So this filtering system, it's awesome. You can augment how you perceive things. You can augment this filtering system so that you can expand it, decrease it, modify it in any way that you want. And a lot of people, they don't know that. They think that what they see is what they see. But no, you can change what you see, perceive, feel, all these kinds of things, experiences, emotions. It's our limbic system. Through this RAS here, functions as the arousal system there for the cerebral cortex. It's crucial there for maintaining consciousness, language, speech center area in the frontal, parietal and temporal lobes, emotion, subjective experience and objective expression of emotions, okay, memory, and we know that memory is all tied to experience. And you have to think there that in rare cases, but not too many, there is an association with remembering something as a child, and we really don't start to remember things until we can actually apply a name for them. And our language development, it starts in, year 1, year 2, we start speaking or talking or recognizing words and, apple, and it's at that point in time there that we are actually able to input a memory. So there's some association there with memory and language. The cortex is capable of storing and retrieving both short-term and long-term memory. Okay, I got a movie here on this one. Oh, come on. What's going on? There we go.
Hello everyone, I wanted to share something really neat with you about how our brain works. There's a part of our brain called the reticular activating system. And this part of the brain basically filters out all the millions of bits of information that are coming into our 5 senses at any one given time, and only allow information to come in that fits in with what we are looking for in life, what we believe about ourselves, who we think we are, things of that nature. I don't know if you remember the last time you were looking for a car, for example. Say it was a white Prius or something like that, and then you happen to notice that there's a ton of white Priuses all over the place at that time. You didn't notice them before that, but now all of a sudden you start noticing them all over the place. Well, that also works in areas of life like the love that we're looking for and the resources we're looking for in our business and our financial life and all different kinds of areas. And how we can train this part of our brain to allow in the information and the resources and opportunities that we're looking for in our lives is by, first of all, asking yourself what it is that you would like to be experiencing. By getting really clear about what you want and even maybe having goals in that direction and saying, gosh, I would really like to have this experience in my working life, or I would like to have this experience in my relationships. Even writing it down on a piece of paper and clarifying it for yourself and being very specific helps to train that part of your brain to allow those opportunities to come through your filters into your experience of life and help you achieve those kinds of goals. One of the things that I see people do most often that throws them off is focusing on all the things that are not working for them. And guess what that causes in the reticular activating system? Just more of that. So I just wanted to share that with you. It's a really neat thing to understand about how our brain works and might be able to assist you in achieving what it is that you want to achieve with your life. I hope that helps.
And it's really awesome. And I like what the guy said. You can also filter out the things there that aren't working for you. And this is one of the it's so profound that if something isn't working for you, you can actually eliminate it from your life. You have the power to do that. And if something is working for you, well, you have the power to incorporate it and make it a daily part of your routine. And it's amazing. I encourage you guys to read more on this. It's an absolute, I find it an absolutely phenomenal topic that I would, you know what I mean? I would love to talk about this one for days because I've been practicing this myself over the past 100 million years since I've been around, and it really does. It's a weird one, and it's in here, and it's awesome. It really is, and I hope you guys enjoy that and practice that and do a little bit of research on your own. Okay, change your life if it needs changing. What do we got here? Hypothalamus. We're still dealing with the diencephalon. Okay, right in there. Okay, sorry, that's in the way there. I'll try and put that somewhere. There we go. Links the mind and the body because basically, this is your there's your spine, your brain stem here, and the diencephalon sits at the top of that. So it kind of does, in a matter of words, attaches the mind to the body. Links the nervous system there to the endocrine. We'll get into that there more when we get into hormones and endocrine there, week 12, 13. Okay. The autonomic activities. absolutely regulates these. The something happened here. It's a major relay station. Sorry about that. That is what happened there. Major relay station there between the cerebral cortex and the lower autonomic centers. And we're going to get into the autonomic nervous system there later on. Little bit. Okay. Synthesizes hormones there, secreted there by the posterior pituitary, which I'm not going to go into any detail on because we're going to hit that like a dirty sock there week 12 anyway, okay? Good. Where are we here? The pineal gland, I'm just throwing this in here. They're located just above the, in the midbrain, okay? It's involved in regulating the body's biological clock. Interesting. Produces melatonin. Interesting enough. Okay, timekeeping. The ability there to sleep at night, wake up in the daytime. All right, and like when I was younger there, in your guys' age there, I worked at the Honda plant, and which is a great job there. If you haven't sent your resumes out yet, or they have a chemistry side there at the Honda plant out in Alliston. It's a very good job. Honda Canada Manufacturing. It's in Alliston. Have a look at it there. Always, if you guys need jobs or anything like that, let me know. I got a whole whack of them there all over the place. I don't, but I know where you guys can go digging. But I understand. I've worked shift work, where you'd work 2 weeks days and then 2 weeks nights and then 2 weeks days and then 2 weeks nights. And it's a tough one. Some people, they enjoy it. I did not. And that's what the pineal gland is all about, regulating this. Okay. And you can see how we're not going into crazy detail because I can't. I got to start and finish this thing in 3 hours, and I don't like teaching for 3 hours straight because I'm just going to bore you guys, and you'll probably see me fall over from sleeping as well. So we're just kind of going through this in a, not quickly, but in a shallow fashion. I really encourage you guys to read the book, okay? And you see, this is my book here. I've got it here. Whether you guys have the e-version or not, the e-version would probably be a lot lighter. This thing is like 4 kilograms. But this book here is actually really good on this kind of stuff. So, and if you ever wanted to have a good night's sleep, read this there just before you go to bed. Yeah, it's a good one. Okay. We've got, now we're down into the brainstem. We've moved on from the diencephalon. Okay. We've got the medulla oblongata, which we'll get into a little bit more detail there. The vital center, the emetic center, your ability to vomit, throw up, stems from the medulla. There's your pons right here. It's kind of on the side of the stem, located above the medulla and below the midbrain. Okay, contains reflexes mediated there by the 5th, 6th, 7th, and 8th cranial nerve, which we'll kind of hit on there later on. Okay, when we get into the PNS, your pneumotaxic sensors there that help regulate respiration. Like the whole idea there that you watch these old TV shows and the child is mad at the parent and the child says, well, I'm just going to hold my breath until I get what I want. And yeah, it's so funny there. My kids tried to pull that on me there last week. And I go, yeah, go for it. Just, here, sit down. And they go, okay, I'm going to sit down and hold my breath. I go, yeah, that's fine. And wouldn't you know it, about 10 seconds later, Dad, you're so mean. You were going to let me die. And I go, no, you're not. That's why I got you to sit down. You hold your breath long enough, you'll pass out. As long as you don't hit your head and go unconscious, and you're going to start breathing again anyway. And so you don't get that chocolate bar. Good. Your midbrain, okay, that's, I apologize, it's really not a good caricature. I've got some other slides coming that are better, but I just threw this in here there. Reflex center there, located above the pons, below the cerebrum, okay. Inferior Forms the midsection of the brain, contains centers there for certain cranial nerve reflexes. So midbrain reflexes. But we'll get there. There's more to come. The medulla oblongata. There's somebody here. I don't really know what to do. They'll have to go away. The medulla oblongata transmits all ascending and descending impulses between the brain and the spinal cord. I will say that again. The medulla oblongata transmits all ascending and descending impulses between the brain and the spinal cord. Okay, it's kind of like the middleman, middle person in between. It houses nuclei there that control the visceral functions. Visceral, again, is organs. Cardiac, vasomotor. Okay, your veins. Vaso means vein, so here we're talking veins and arteries. You have, when the kidneys there, they need increased blood pressure. Okay, vasoconstriction, vasodilation. This is all the medulla. We have the respiratory center there that works along with the pons to control the rate and depth of breathing. Okay. Other nuclei in the medulla are associated with coughing, sneezing, swallowing, and vomiting. Okay. That's your medulla. That's your midbrain in a nutshell. You know what I mean? As I said, I could do 100 PhDs on just the pons, and we're not. All right, so any information here on the PowerPoints, that's what we're looking for. The book does tend to go into some good detail. I encourage you to read it. If you guys read this, you know, these chapters there on the CNS chapter, was it 19, 20, and 21, as far as the test goes, you'll get 150%. So that's where we're at. But if you just stick there to the slides, you'll be just fine as well. Moving on to the cerebellum. This is at the base of the brain. Functions, and you'll see it here by the diagram. It's this chunk right here. All right, there was your brain stem there. There's your midbrain, and this is your cerebrum up here. But the cerebellum there functions to integrate sensory information about the position of body parts and coordinate skeletal muscle activity. Interesting. What do you mean the position? How do we know where, I know where my nose is. Well, then close your eyes. See? How do you know where that, that's the cerebellum. It's able to track where body parts are, going, and then to. Okay? Involved in skeletal muscle activity as well. Skeletal muscle control. It's the second largest part of the brain, contains more neurons than the rest of the nervous system. Isn't that interesting? Functions, motor commands, okay, acts with the cerebral cortex there to produce skilled movement, finesse. Control skeletal muscle to maintain balance and control, okay, regarding posture, sitting up straight, standing, walking straight. These are most things there to do with motor coordination. Now you're talking cerebellum, okay, as well as sensory information in accordance to movement, okay. Well, we're making good time. I am very impressed. Now we're into, and you see what we've done here. I'm just going to go back here. I always screw these up here and go back and forth and have some fun with these. But where did that go? This is the one I want. So basically we've covered all of this right here. We've covered the cerebrum. We've covered the diencephalon. We've talked a bit about the midbrain, the pons, the cerebellum, and there's my medulla. And now we're moving on down here. We're going to talk a little bit about the spinal cord. Nothing too crazy. As far as skeletally, is that even a word, skeletally? Can you talk skeletal? No, you can't. Anyway, as far as the skeletal system goes there regarding the spine and all that, I will leave that for Bio 1032 because you should go into some good detail about the different types of vertebra, the cervical, and just to know your cervical vertebrae, okay, they're at the top, not involved in weight bearing, just more for movement. Okay, then you have your thoracic vertebrae down below, and they have attachments there that allow for the rib cage there to articulate. And then the bottom, you have the lower lumbar. They're the weight bearing, okay, because they've got to hold everything up above. They tend to be thick and heavy boned vertebrae there. They have a big body at the back. So, and as far as any details skeletally, I'm not hitting it. Okay, I'll leave that there for Bio 1032 because you do a good job on skeletal and muscle there. Okay, but that's where we've covered there the brain in a nutshell. We skimmed over it in some fashion. We covered, can you believe we covered the brain in an hour? Ridiculous. But it is what it is because due to the course constraints. Okay. Just moving on through. There we go. So what we've down now we're into the spine, and you'll see there that the spinal cord actually projects up through the base of the skull. Okay, your occipital bone there, and there's a big hole in the bottom of your occipital. Okay, and it's called your foramen magnum. Foramen just means a hole. Okay, and we have foramens all over us to allow nerves to go through our cheekbone, zygomatic bone. You have foramens all over the place that allow blood vessels and nerves and these kinds of things to go through. And so that's called your foramen magnum. Okay, and you'll see here that the spinal cord is basically just a continuation of the brainstem. That's all it is, right? Tube-like structure located in the spinal cavity. Now, all organs have their own cavity. And yes, there is a cavity that is designed to house the spinal cord. So it's just not moving around and sloshing around. We just don't want our spinal cord moving around because all these little the vertebral bones, okay, they're separate. They're their own thing. And when you got bone on top of a bone, 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 and continues on, and you've got all these articulations happening, there is huge problems there regarding injury, especially the lower lumbar. Trust me, I know. Take care of your back. When you're picking up anything, bend those knees. Good. The extends there from the foramen magnum, which is up here, all the way down to L1. And you'll see there that your spinal cord doesn't go all the way down here to your coccyx. You know, you got your sacrum and your coccyx. If you do not know what a sacrum is or your coccyx is, have a look at it. I'm not going to test you on it, but you'll see there. See if I can kind of zoom over a little bit here. And you'll see there that your spinal cord actually finishes well before. Like there's your sacrum, coccyx down here, and you'll see that your spinal cord goes down to about here, which is the bottom of your thoracic. Sorry, I'm zooming all around here. I apologize. Just and you'll see here the end of the spinal cord, right about here, L1. Okay. And then you'll see here what's called your cauda equina. And you'll see that it's this ganglia kind of, you'll see here that that's what's going on down below. We'll get into all this stuff there when we get into the PNS. But you'll see there that all these nerves are coming off of the spine. And you'll see that they're coming off in pairs. But we'll get there. This is just an introduction there. Okay, so that's your spinal cord location and size. Okay. I don't really know where to put this. I guess I'll put that over there. Good. Here we're talking gray matter. okay, as opposed to white matter. We've kind of covered this in a little bit, right? White matter there is, you'll remember your saltatory, how with the myelin sheaths, you get the saltatory conduction, which jumps those myelin sheaths, which is actually faster than gray matter, okay? Can you guys hear that now? If there's any issues there, if you guys can't hear or anything like that, please let me know, okay, if there's any issues at all, because I'm kind of seeing, I can see, I've got this reduced, I can see some students here, but I can't see any type of comments. So if there's any issues, just somehow get a hold of me, let me know, and we'll fix it up there while we're doing the video, okay? I want you guys to have access to this. And if you got to scoot, if you got to go, if you got to work, if your kids are screaming and they need food, go and feed your kids, go and do whatever you need to do. I'm recording this right now and I'll post it. Might post it there to YouTube, or we can hear your voice, but the connection maybe not good. We can't hear you properly. I'm not sure what to do. But even if you guys can't hear me, screen is also not visible now. I'm not sure. You may want to check. Okay. Even what I'll do, some of you guys can't hear or see. That doesn't make me happy. But what I'm going to do is, even if you can't hear or see, or there's an issue of some kind, okay, then I will post this and you guys will hear it and see it perfectly there. So if there's, I don't know what's happening with the internet, who knows, maybe Martians have arrived and the internet is being taken over. I don't know, but regardless, I am recording this and I will post this as soon as I'm done. So this whole 2.5 hour lecture will be available at 3 o'clock, and you guys can watch it as many times as you want. So that's where we're at, and hopefully you guys can hear that. If you can't hear it, I'll post the video and everything will be fine. Okay. The white matter there, the myelin sheaths, okay, saltatory conduction. The white matter there contains tracts that carry information up and down the cord. Tracts are composed primarily of groups of myelin and axons. Most tracts there, they're great word here, decussate, thank you, or crossover, all right? And I just wanted to say crossover, but I thought I'd sound smart and say decussate, but it didn't really sound that way. It didn't sound intelligent. I don't know what to do. If you guys can't hear, then I'm just going to keep on going, okay? And if you guys cannot hear, what's happening here? Here, what's happening? The pause, share, mute. No, everything is good. I'm speaking all right here, and I can get this, but I guess it's the internet. So if there's any issues, we'll continue on, and the audio, the video will be posted there later on. Okay? So that's the best we can do for right now. Okay? The gray matter there, columns of gray matter extend the length of the cord, dorsal horn, ventral horn, and central canal. Okay, in transverse sections there, looks like the letter H. And you'll see there that there's a letter H. And you'll see there the ventral horn is your anterior. Okay, so this will be the front. Your central canal, and then you've got your dorsal horn, which is your posterior. Okay, so this is the back, this is the front. Okay, so the white matter again, all right, the most tracts there, they cross over from one side to another. And we've seen that there before. The right side of the brain controls the left side of the body. Okay, surrounds the gray matter and is subdivided into halves of the cord into 3 funiculi, anterior, posterior, and lateral white columns. Okay. Names of spinal tracts indicate the location of the tract, the axon origin. What was that? Weird things going on here. Okay, but that's that one there. Moving on there to the peripheral nervous system. Okay, it consists of now when you're talking the central nervous system, again, that was the brain and the spinal cord. Now, how do we receive sensory input? Well, if I just burn my finger or something like this, right, the information travels along my arm to wherever it needs to go in the CNS, and then the CNS there makes a decision, and then that message is sent back. You know, you guys will remember an afferent as opposed to an efferent. Okay, afferent is a sensory. Okay, and you're receiving a message, and that message is coming from my finger to the brain. So it's at home. I remember afferent nerve as at, annotate the shared. You cannot control the shared content until you stop annotating. During annotation, you cannot control the shared content. Loveline, I don't know what this is. So I'm going to decline it. Okay, for right now. If you guys can't hear this, or I'll post the video. That's the best I can do for right now. Okay. The afferent means at home. So this message is coming to the central nervous system. Afferent, at home, sensory. Okay. The efferent, this is exit. Okay, it means it's leaving the central nervous system and going out to the finger.
Professor?
Yes. Hello.
I really can't understand
Well,
the words.
uh,
Your voice keeps cracking.
and this is what I'm saying. Oh dear. This is what I'm saying is that if there's something wrong with the internet, I am recording this. So I will post the video, and I don't know, I guess you guys can't even hear that. So if you
Yes,
can't,
we couldn't understand earlier that you said you were recording it.
oh yeah,
Sorry.
I've been recording this for the past hour and a half. So everything will be recorded, and I will post it. Sorry, the internet is, I'm going to have to call Rogers, I guess, and see what's going on. But that's what's happening here. I'm recording this and I'll post this. So if you guys can't hear this or see it, then I'll post the video and everything will be fine. Okay? So, afferent and efferent nerve. Okay, afferent means it's coming home. Efferent means it's leaving. It's going back to the finger. It's a motor nerve. Okay? So, that's what we're doing there. And I don't know why I can't. It's crazy, man. I can't get back to my main screen here. Here, I'm going to stop sharing for a second. And hi, guys. Hi, class. If you can't hear, no worries. I'll post the video, the recorded video, and you'll see it then. Thanks. I don't know. Don't know what's happening with the internet. Everything will be okay. There you go. Okay. So what we'll do is we'll just keep on going. And there we go. Okay. So we just talked about there afferent and efferent. Okay, very important. Afferent there, the dorsal division, nerve fibers there that convey impulses to the CNS from the sensory receptors. The efferent, okay, motor or ventral division carries impulses from the central nervous system to the effector organ, muscle, gland, my finger, that kind of a thing, okay? The nerve attachments there to the spinal cord, dorsal and ventral. So which types of fibers are associated with each root? So you got the dorsal, which is the back, and the ventral, which is the front root. They're attaching there to the spinal nerves of the spinal cord. And you'll see how it goes right here. The central nerve fibers there from the peripheral travel to the cord through the dorsal root. And you'll have a look. So, sensory, something happens there on the skin, you feel something, and the message travels, okay, through the dorsal root, around, okay? We'll get into what a ganglion is later, okay? And then we've got the ventral root here. There, the dorsal root ganglia contain the cell bodies of the central fibers there that are gathered together. The motor fibers there comprise the ventral root, and that's how this one works. Okay, so there's your dorsal, okay, through the back, ventral, there you go, through the front. And there's your effector. There's your muscle movement, okay? All right. I'm really sorry there that internet isn't working. You count on that, right? The structure of the spinal cord there, we have the nerve roots, okay? You have the dorsal nerve, which tends to be unipolar, okay? Sensory neurons. The ventral root there, multipolar, okay? These interneurons there are located in the gray matter, okay? And you guys remember there your cauda equina. We'll get there when we look at the spinal nerves. The cranial nerves, okay, that allow us there to do things with our face, okay? There's 12 of them. And you guys can have a look at these. Again, this is right from your textbook. You have the, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? The olfactory, optic, ocular motor, trochlear, trigeminal, abducens, facial, vestibulocochlear, okay? And you've got these ones here, the glossopharyngeal, the vagus. That one there is probably the most famous. I'm sure you guys would have heard of the vagus nerve. It does a lot. Accessory and the hypoglossal. And you guys can have a look at these, okay, just for a matter of time. You know what I mean? I'm not going to go into all these, but you guys can have a look there at that has all 12 and what they're doing. That one there would be a good one there. Guaranteed you would see something on the test next week. You know what I mean? I'm not going to go for, I'll tell you which ones I'm not going to go for. You know, the ones there that are difficult to pronounce. The vagus one I like. The olfactor, the optic, ocular motor, the trochlear. These ones there are good ones there. And they're quick and easy and an easy little thing to look up. You get your mark, move on to the next question. Okay? The spinal nerves. Okay, there are 31 pairs of spinal nerves that exit the spine cavity. Okay? And great one there, these introvertible foramen. Remember these holes there? We have them all over. Your spine has them. Okay, each vertebra has them that allows for nerves there to flow through. And that's the trouble, is that when one of these vertebrae, they get crushed in some fashion, car accident, lifting accident, whatever it is, those little foramen will get and then what happens there? We have nerve damage, right? So there's cervical there, 8 pairs. The thoracic there, 12. The lumbar is 5. Sacral is 5. And coccygeal there is 1. You just have a look at these right here. The names of the vertebrae are given on the left and the names of the corresponding spinal nerves on the right. They go from T2 to T12, where there is the all but nerves T2 to T12 subdivide to form networks called a plexus. Now, what are plexus? We'll talk about these right here. So you see there, you have your cervical, okay? You have your thoracic, and from here down to here, there really isn't any of these plexus. And what is a plexus? It's a branching network of intersecting afferent and efferent nerves, which I'll get into there. There's 4 major pairs of plexus. There's cervical, thoracic, lumbar, and sacral, and you'll see them all right here, okay? And you see the nerves coming right off, all right? That's what's going on there. Are we going to go into any crazy detail? No, all right? Being able there to see these guys. What we've got here, again, this is right from your book, and you'll see there what's going on. And apologies there for just reading here, but your book is great. Rami of the spinal nerves. Note that the ventral and dorsal roots join to form a spinal nerve. The spinal nerves then split into a dorsal ramus, which is the ramus there is plural for rami. Okay, ventral ramus there. The ventral ramus communicates with a chain of sympathetic ganglia by way of a pair of thin sympathetic rami. And this one here is A, and both of these, they came from, it's diagrammed, see 21.3b, and this one here is the same, 21.3a. It's from the same page. So I encourage you guys to have a look at this. It's neat just to see how it all works there together, okay? And then we have this one here, Rami of the spinal nerves. Again, note that the ventral and dorsal root join to form a spinal nerve. The spinal nerve then splits into a dorsal ramus, okay, and a ventral. Of course it does. It has to. It's got incoming and outcoming. And the ventral ramus there communicates with a chain of the sympathetic ganglia. And it's really neat. Have a read of this. Don't go too crazy on it, but you'll see there that this happens at every single vertebrae. Interesting stuff. The plexus, and this is a new. I didn't include this there in my last year when I was teaching this, and I just updated it there this year. The whole idea of what a plexus is, and plexus is, it just means Latin for braid, and like you're braiding someone's hair, okay? And you're braiding someone's hair like this. And these are fibers there of several different rami that join together. And you'll see here that you'll have a nerve there from C4, C5, C6, C7, and C8. These are cervical, right? Okay. And you see what happens is they intertwine. They braid each other. They go into each other. Now you think, why would it do that? What's the biological advantage? And each of these individual nerves there that emerge from a plexus there, they contain all the fibers that innervate a particular region. Innervate means to conduct, right? Nerves innervate. The destination of each nerve serves as the basis for its name and are rearranged according to their ultimate destination. The whole point of a plexus there is it reduces the number of nerves needed to supply each body part. Because if you have a nerve coming here and a nerve coming there, well, that takes up a lot of space. Okay, so we might as well combine them. And that's what this is going on. You're combining them to conserve space. Okay, and because each body region is innervated by fibers that originate from several adjacent spinal nerves. So you see here that if I want to get to, I don't know, I want to get down to this point. You see this one here, the radial nerve. There's different ways that you can get to it because of this braiding. So if one pathway gets damaged, there is the possibility that the neural pathway will continue via these plexus, okay? And we can circumvent damaged areas to keep things moving, okay? Because each body region is innervated by fibers that originate from several adjacent spinal nerves, damage to one spinal nerve does not mean a complete loss of function in any one region. So that's what these plexus are. And you know what? I think they're really interesting and something there that you will definitely see at least one question on the test there from that. Okay. Oh my goodness, it is 1:50 already. What I'll do is I'll finish up this slide and we'll take another 10-minute break. And what I'll do is I'll stop the video. I'll go on mute and we'll take a 10-minute break, and then we'll finish this thing off after 2 o'clock. Okay, so let me finish this slide here. The nerve pathway, the route. Here we're talking about the reflex arc, and we've spoken about this already. The whole idea there that information doesn't necessarily have to go to the brain in order to cause a reaction. When you're talking there, the reflex arc here, this one doesn't, and I think I have this. This is the movie here that I want to, that's it.
In a reflex arc, sensory information is processed at the level of the spinal cord, resulting in action without involvement of the brain. For example, if one's fingers are burned by a candle, the hand that receives the painful stimulus is rapidly removed from the flame with a jerking motion. At the same time, the brain is receiving information indicating that a painful event occurred in the hand. It is important to understand that although the brain may perceive the painful stimulus, the reflex arc acts to retract the hand without direct input from the brain. In a reflex arc...
Sorry. So that's what we're talking about there with the reflex arc, is that the sensory reception, the receptor, okay, there's a problem. And the sensory neuron carries the problem there to the CNS, central nervous system. It does, while a message is then sent to the brain, another message is sent right back to the hand to get that hand out of there. So the pain that the brain is feeling is kind of after the fact kind of a thing. And the brain is not involved in that jerk motion to get your hand out of the way. That's just an evolutionary trait that's embedded within the spinal cord. All right, but which then causes the effector there to move the hand out of the way. But yeah, interesting. But what we're going to do is we'll take a timeout, and I totally apologize. I can't believe the internet is it saddens me. It really does. But we're going to take a 10-minute break, and what we'll do is we'll start it up. We'll start it. I don't know, we'll start it up in 10 minutes at 2:02. Thanks, and sorry for the bad internet. Okay, let's stop it up. Mute.